Hi, everybody. So this is part 2 for section 11.4. And in this part, we will cover objective 2, which is to solve inequalities that contain rational expressions with variables in the denominator. So let's skip all the way to here. All right, so the idea behind solving rational inequalities is very similar. Remember in the first part, we talked about the only place that polynomial functions can change sign between positive and negative is where the function crosses the x-axis. In other words, where the function equals 0. Well, rational functions can also change sign at those points, which means we will need to find those points. But rational functions can also change sign at values of x that make the function undefined. So in this example here, this function changes sign at -3, where the function equals 0. It also changes sign at -2. It changes sign at 0. The function is undefined at both -2 and 0. And it changes sign at 1, where the function equals 0. And it also changes sign at 2, where the function is undefined. So moral of the story, at the beginning of these problems, we will need to figure out, number 1, where is the function undefined? And number 2, where does the function equal 0? And those are what are going to be called our boundary points. Those are the points that we plot on the number line to start with. So the steps are exactly the same as they are for solving polynomial inequalities, except we are inserting a new step 1 at the beginning of the process. We're going to solve for values that make all denominators 0. And then if you look at steps 2 through 5, they are exactly the same as the old steps 1 through 4. There is one more little exception. At the end, when you're ready to write your solution set, the values that came from step 1 will automatically, every single time, be excluded, because remember, they make the rational expression undefined, so they can't be solutions to the inequality. All right, of course, this will make more sense when we actually do it. So I have these two examples, and I'm going to switch over to the tablet. All right, here we go. So step 1 is to figure out where is the expression undefined. It is undefined when x plus 2 equals 0. In other words, when x is -2. So that is going to be a boundary point. It is automatically not going to be a solution to the inequality. Step 2 is to solve the related equation. This is like the old step 1. So we're going to do x minus 3 over x plus 2 equals 0. Remember, we went over solving rational equations in chapter 7. So I'm going to multiply both sides of this equation by x plus 2. And that's going to cancel that out. And it's going to leave me x minus 3 equals, the right-hand side is still 0. And if I add 3 to both sides, I get x equals 3. So our boundary values are -2 and 3. I'm going to plot those on a number line. There's -2, there's 3, which gives us 3 regions. We'll call them A, B, and C. So now remember what we have to do next. We have to pick a test point from each interval. So for region A, why don't we go with -3? For region B, why don't we go with 0? And for region C, we'll go with 4. Okay. All right. So now I'm going to make my table. So first we go region, then we go test value. Then we write the original inequality, which was x minus 3 over x plus 2 is less than or equal to 0. And then we indicate whether that inequality is true or false. All right, so we have A, B, and C. And for our test values, we picked -3, 0, and 4. All right, so starting with -3, I'm going to write part of the inequality here and then fill in the blank. Okay, so if we plug in -3, we get -3 minus 3 over -3 plus 2, which gives you -6 over -1, which is 6. And is 6 less than or equal to 0? No, it is not. So that is false. Next, we go to region B. We plug 0 into the inequality, and that gives us -3/2 is less than or equal to 0. Is that true or false? That is true, right? And then finally, we have 4 minus 3 over 4 plus 2, which gives you 1/6. Is 1/6 less than or equal to 0? No, it is not. All right. So the only region that satisfies this inequality is region B. So let's go back to the previous slide. We will color in region B. Okay, so now we have to think about the endpoints. This is just a little bit more complicated than what we did before. Okay, so let me squeeze, I guess this is called step 5. Sometimes I don't remember where step 3 becomes step 4 and step 4 becomes step 5. As long as you do all the things on the list, it doesn't really matter. Okay, there we go. Okay, so number 1, x equals 3. That came from step 2. That is included because the inequality symbol is less than or equal. This is just exactly like it worked in part 1, okay? However, the value we got from step 1, which was -2, is automatically not included because it makes the expression undefined, all right? So the values from step 1 are never, ever, ever solutions. So when you go to finish this picture, put a round circle at -2, put a closed filled in circle at 3. And the way that you write this solution set using interval notation is you put a parenthesis next to the -2 and then a bracket next to the 3. And that's how it works. All right, so now let's try the next example. Okay, p over p plus 4 is less than or equal to 3p. All right, step 1. Expression or values that make the expression undefined. That would be when p plus 4 equals 0. That would be when p is -4. That is automatically not going to be included. Step 2, we're going to solve the related equation, which is p over p plus 4 equals 3p. Okay, good old rational equation, just like we saw back in chapter 7. We're going to multiply both sides by p plus 4. So these are going to cancel. And that's going to leave me p equals, why don't we go ahead and distribute this 3p. That gives us 3p squared plus 12p. All right, so that is now a quadratic equation. Usually we solve quadratic equations by putting them in standard form. So this is now going to say 3p squared plus 11p equals 0. We'll solve that by factoring, by taking out a p. P times 3p plus 11 equals 0 would mean that either p is 0 or 3p plus 11 is 0. Okay, so at this point we have 1, 2, and then when 3p plus 11 is 0, that means p equals negative 11 thirds. So in this problem, we have 3 boundary points, all right? And since I've run out of room on this page, I'm going to go over here. I'm going to draw my number line. Okay, now I've done this problem a bunch of times for various classes. -4 and 0, no problem. Negative 11 thirds can also be written as -3 and 2/3. So that's kind of going to be a little bit of a pain. You'll see why in a second. But definitely make sure you put the -4 first, and then the -11 thirds, and then the 0. Okay, so that gives us a total of 1, 2, 3, 4 regions. All right, so now I will, you know what I think I'm going to do? I think I'm going to spread my chart over 2 pages. I don't want to try to cram it in here. We still need to pick our test values, though. We haven't done that yet. Okay, we're going to put our inequality here, which the original inequality was p over p plus 4 is less than or equal to 3p. And then we want to know, is that true or false? All right, so we'll do these two on this page. We'll do the next two on the next page. All right, so test values. Pick a number, any number that's less than -4. How about -5? Okay, I'm going to come back to region B and do that one last. Pick a number, any number that is between -3 and 2/3 and 0. So the obvious choices would be either -3, -2, or -1. Oh, why don't we go with -2? Pick a number, any number that is greater than 0. Well, you can use any positive number. How about 1? Okay, so here's why region B is a pain. We have to pick a number that is between -4 and -3 and 2/3. So my suggestion would be to think of -3 and 2/3 as a decimal, which would be -3.66666. So how about -3.8? Unfortunately, we cannot use an integer here. Okay. Don't worry, this is not going to happen in most problems, I think. All right, so far we have -5 and -3.8, and then we'll do the other two on the next page. Okay, so when you put -5 in this inequality, here is what you get. You get -5 over -5 plus 4 is less than or equal to 3 times -5. -5 over -5 plus 4 is -5 over -1. And we want to know, is that less than or equal to -15? In other words, is 5 less than or equal to -15? Well, no, I don't think it is, right? Okay, and then if you put -3.8 in here, let's see what happens. Might need a calculator for this one. negative 3.8, negative 3.8, negative 3.8. Okay, the left-hand side would be negative 3.8 over positive 0.2. And I believe that comes out to negative 19. So the question is negative 19 less than or equal to negative 11.4? Well, yes, it is. All right. So far, region A is not part of the solution set, but region B is. So let's go ahead and color in region B. Okay, and now I think what I'm going to do is I'm not going to go to the next page. I will just erase what I have in this table. So make sure you have it written down. Pause the video if you need to. Okay, so we will just recycle. Okay, and I think the easiest thing would just be to do these from scratch. All right, here we go. So now we need to do region C and D. We have test values -2 and 1. So starting with -2. If we put a -2 there, that's going to give us -2 over 2, which is -1. Is -1 less than or equal to -6? No, it is not. All right, and then finally, (1 over 1 plus 4 less than or equal to 3 times 1. That would give you 1/5 is less than or equal to 3. Is that true or false? That is true. All right, so region C is not part of the solution set, but region D is. All right, so now all we have to think about are the boundary points. So let's go back to the last slide. Anything that comes out of step 1 is automatically not included. The values that come from step 2 depend on whether your inequality includes equals or not. And in this case, it does include equals. So these two values are going to be included because the inequality is less than or equal and not just plain old less than. So we're not going to include the -4, but we are going to include the other two boundary values. So that is going to look like this. All right, so when you write your solution set, and I think I'm going to write it directly underneath if that's okay, because I've always thought that interval notation is easier to write if you have the graph in front of you. Okay, so it's two separate intervals. We're going to have to use the union symbol. The first part is going to be parentheses -4, comma, -11/3 bracket. And then we're going to put a union. And the other part is going to be bracket 0, comma, infinity. And remember, next to an infinity symbol, you always, always, always use a parenthesis. All right, and that is going to do it for section 11.4. So we'll see you next time.